Hi, everyone. So thank you guys for joining this webinar with Daniel Swa. He will be joining us shortly. He's putting his kids to bed. But for all of you guys who have never used GoToWebinar before, I just want to briefly talk about the functionalities. So on your right-hand side, there is a questions box. If that's not automatically open, you can click on it on the drop-down. And for at any point of this webinar, if you have anything that you would like us to elaborate on, or if you have any questions that you would like to ask Daniel, that you could type it in here in the question box and click on send, also at the bottom right. And if you would like to have our attention and share your feedback or some sort of, if you have any other questions, there is also a little icon that's in an image of a hand, and it's to raise or lower your hand to call us to let us know that you would like to interrupt or interject to further discuss something. And yeah, so we will be beginning in 5 minutes. We're still waiting on a few more people to join, and we're also waiting on Daniel. And so I'll just start off by talking about KTBYTE. So KTBYTE is a computer science academy. We teach students ages 8 to 18 computer science. And so we have classes that are progressive, and our classes start from beginners programming with Java blocks, which is a program that we've developed that allows for drag and drop programming. So it's a drag and drop programming language. And to intermediate classes, to advanced classes where students can compete in this competition called the USACO, which is the USA Computing Olympiad, also to apply for research programs like MIT Primes or even Google Science Fair, etc. And yeah, so Vikram here is one of our students and also TAs our classes. So Vikram, do you want to introduce yourself?
So hi, I'm Vikram. I'm a student at KTBYTE. I also TA one of the fun courses and one of the earlier CS courses. And yeah, so I have been taking KTBYTE for I think for like a year.
Oh, wow.
And
Yeah, I think I already have, and now my beautiful face is on the
Webcam?
webcams. Yeah, that technology of which you speak.
Thank you. Okay, awesome. All right, so let's get started. So I briefly just introduced myself, and Vikram is one of our students. I think you weren't here for the initial few minutes, but yeah, so we'll both take turns asking you questions. And
Okay.
so start off with the first
I'm also here right now.
Oh, hi, Pat. So Pat's also joining us. He's another one of our students, but also now he works mostly as a software engineering intern. And he was a TA before, but mostly now he just
Okay.
Yep.
Got
Yep. We'll start with the first part, which is about your education, and if you have any advice to provide with our student viewers and also parents who are thinking about or who care about their students' education. So if you could start off with telling us about your educational background.
That is an incredible first slide. Okay. Brief self-introduction. So I was a computer science and statistics graduate from Harvard undergrad in 2010. I spent a number of years in industry, and now I am a PhD at Princeton doing computer science.
Okay, perfect. And also Pat goes to LHS currently. And
Wow.
Yeah, and I believe Vikram's brother also goes to LHS, so I've assembled a team of LHS students. Yeah. Okay.
That's nepotism, if I've heard anything.
Awesome. And then also okay, so the next question is, how did you get into computer science?
So there's a neat story about how I got into computer science and the actual story. The neat story, of course, is, oh, computer science, there's this wonderful trend of software and blah, blah, blah. But the true story is a little bit messier. I never actually planned to get into computer science. I was an old friend of Ben's, and when we did projects in high school, Ben, he was always the one doing all the computer stuff. And I always just assumed that I'm not good at that sort of thing. He said I should take some computer classes, so I did. In high school, I think I took AP Java or whatever existed back when I was in high school. But I felt I wasn't very good at it. And it wasn't until college that I thought I was going to be a physics major, and I sat in on one class that happened to be in the same room as my physics class. And it was computer science. It was like graph theory or something like that. And I was like, oh, this is interesting. And I didn't think too much about the computer science-ness of it. It was just a class, and there was a professor standing in front of me. And much like, when you're in elementary school, you sit in one class, and the language arts teacher comes, the history teacher.
You passively just absorb information.
Exactly. So I was just sitting there, and the graph theory teacher came, the theoretical computer science teacher came, the systems teacher. So I was just sitting there. I didn't want to move from my seat because, lazy college student, and I was a physics student. And all of these, it so happened to be in the computer science building, and all of these computer science professors came in and they were teaching their classes. And I was like, one after another, I said, wow, that's a class I want to take. And before I knew it, all my classes were computer science, and the semester was over. And I had fulfilled almost the entirety of the computer science requirements at Harvard, which are very low. So if you want to be a computer science major, go to Harvard. They're very low. And then it didn't make sense to be anything else. So I was like, okay, I'll do computer science. So that's the real answer, the messy answer.
Okay.
And yeah.
And what is your answer for the answer that you give people that's like maybe not the real answer?
Oh, okay.
Actually, while you think on that, Vikram, can you share why you started studying computer science?
I was about to have some hand motions and everything. No, sorry. Go ahead, Vikram.
So why I started studying computer science, there was just like this course that I found online. It was like learning Python. It was like its most basic level. So I started doing that, and then I thought, oh, this is pretty cool. So I took more courses on that website, and I'm like, okay, this is still pretty cool. And then during that time, my brother, who goes to LHS right now, he was doing classes at KTBYTE. So then he sort of got me into doing it, and now here I am.
We didn't ask Vikram to give us a plug, by the way. Okay, so I see. So it's definitely very different from Daniel's journey. Awesome. All right, so actually, Vikram, would you like to ask the next question?
Yeah, so what did you like most about CS then? And is that still what you like to do? Is that still what you like about it now?
Sure. At the time, as a young, immature man that I was, boy, I should say, I was most attracted about CS because for me, not for everybody, for me in particular, CS was the easiest thing. It was easier than English. It was easier than history. For other people, that may be different. And so that is why I gravitated towards it. I think now I have a greater appreciation both for the challenges in computer science and also why the merits of other fields that I feel a little bit differently, but it's still the same. Computer science just was a little bit more of a natural fit for me.
If you would break it down into like what exactly about the subject you think makes it easy for you, or like because I mean I personally would I personally have a more of a design and arts background, so it's more of a struggle for me to learn it because I don't think in the same way that a lot of like you or Ben do for most cases.
Sure. One of the things that really makes computer science unique is that you have such a fast and accurate feedback loop. So let's say you do something wrong, you write a program and it has a bug. Immediately you have a response. It's wrong. And then some people are bad at debugging and they do all kinds of random things and it takes them forever to debug. But if you're very focused on debugging, it's actually a relatively quick process. And you find, okay, this assumption that I had was actually totally wrong. I should not do that. And then I need to do this new thing instead. So I have a little bit of experience with mechanical engineering, and it's totally different. In mechanical engineering, if you get something wrong, maybe you destroyed a part that
Uh-huh.
you needed, or maybe you need to order a new part. And this is in mechanical engineering. Then my friends in biomedical engineering, oh my goodness, if your reagents are wrong or your the bacteria you put in a solution is wrong, then you're set back months at a time. So the key that I'm looking at is the iteration cycle. And in computer science, we have the great fortune of having this very fast feedback loop that other sciences may not have that luxury. They're still, extremely important, and people should go do those things. But
Yeah.
in computer science, we have it a little bit easier in that way.
I see. I see. Okay. Yeah, I think that's a great answer. It definitely also informs a lot of the culture within a lot of tech companies where it's like you're constantly trying to build really fast,
Break
iterate.
things.
break things, iterate. That's what Ben always says.
Right.
Iterate, fail fast, and iterate. Yep. Okay. Cool. And then the next question is, how has your education benefited your career? So your experience at LHS and also at Harvard, and then currently at Princeton.
Sure. Um, so there were some questions in general about the relationship between school and career. And my general feeling is that it absolutely matters what your education is relative to your career. I'm not going to say that it does not, but it matters less and less than people think it does. So I am not going to say like, okay, go to forget about school, do whatever you want. I'm not saying that. You should try the best you can in school, but if, for example, the lottery of schools does not award you with whatever that you would like, that's okay because it matters less than it used to. So as an example, my brother, he went to Harvard. My brother-in-law, he went to the University of Michigan, also a phenomenal school. The fact of the matter is they both graduated, and they both went to the same job at Facebook, and they do very, very similar things.
Mm-hmm.
And
I see.
so it really didn't matter. So it matters less where you start and more of how fast you are improving and how focused you are on improving.
Mm-hmm.
And I think the thing that I really wanted to focus on here, because I know a lot of Chinese parents, mine included, is that some of the people that I actually respect the most as computer scientists went to schools you might not have ever even heard of, or you don't even want your kids to go to. So Lehigh, Wake Forest, Arizona State.
Mm-hmm. Yep.
It is important to, of course, try as hard as you can to get into good school, whatever. But it is not the be all end all, and I want to really emphasize that.
Okay. So you wouldn't think that maybe at Harvard you have access to really esteemed professors or like the great faculty. That's not beneficial to.
Okay, all right. I will give you a real answer. So I actually don't think I'm going to censor myself. Harvard is a great school. As far as computer science goes, you know, I think the most important thing that matters for undergraduates is the community that you have. So some schools are renowned for their community. I will say UC Berkeley, for instance. I respect UC Berkeley as an institution for undergraduates much more than I do at Stanford. Now, this may come as a shock to most Chinese parents and Asian parents because of Stanford.
Yeah.
But the truth of the matter is Stanford, a lot of professors, they're going to companies and blah, blah, blah. They're doing other things. But at UC Berkeley, they really have developed a community where you can do really, really interesting things as a very, very junior researcher or a very, very junior software developer that you really you couldn't even do in industry. You can only really do in this kind of environment. And I think that's very special.
How did you find that out, or like how were you able to learn that the community at UC Berkeley would compare it to Stanford be better?
Gossip.
Okay.
As a PhD student, you do hear a lot of gossip from different places. I do not want to belittle any place. Stanford is an incredible place. If you could go to Stanford, go.
Right.
But I want to say, I guess where I'm coming from is more to dispel the myths and rumors, maybe. So, for example, you may believe that UC Berkeley is not as great as Stanford, but if you are thinking from a computer science perspective, a lot of very influential projects have come out of UC Berkeley recently, and a lot of Stanford professors, they're extremely good, but they're focused on maybe other things right now.
Right.
And so what I'm saying is that the calculus is not as simple as maybe the US ranking news or whatever, US news ranking would suggest.
Right. There are a lot of other factors for students when they're looking at colleges than just ranking.
So I have a question on that point.
Okay.
So I also heard that like education in different schools are generally pretty similar once you graduate. People generally have the same information, have the same knowledge, but there's also the thought that at these higher end schools or higher ranked schools, you get to have more connections that in the future give you better opportunities than others, even with the same level of knowledge, wouldn't have those same maybe connections or opportunities. What's your take on that?
So the way I would think about this is the way I would approach a lot of these. How would you decide X versus Y? Most people, when they ask X versus Y, they want an expected value comparison. What is the expected value of X versus the expected value of Y? I think that is helpful, but not a complete picture of a comparison between X and Y. There's a distribution of X and a distribution of Y. And this is not a controversial point. It's very obvious. Let's say X is you go to Stanford, Y is you go to UC Berkeley. I went to neither school, so I have no dog in this fight. So if you go to Stanford, there are a lot of possibilities. On the one end, maybe you linked up with the professor who wrote, Larry Page and Sergey Brin their first check, and that's a really great outcome for you. On the other end, you wound up with a professor who's not really focused on your class at all, and he's checked out doing his own company. So there's a very wide range of experience. And at Berkeley, for example, you may a similar idea. And so what I want to get away from is saying like, oh, obviously Stanford is better, or obviously Berkeley is is better, because that will never be the case because it's a distribution. But the distribution is not irrelevant. So in general, if you are comparing between say Stanford and UMass Amherst, you probably want to go to Stanford. but there are other factors that people don't count as much as they maybe should.
Nothing against UMass Amherst. It's still a very good school. For maybe a few students who have gotten accepted or are going there.
Absolutely not. In fact, I would say at UMass Amherst, you have an incredible number of opportunities to do really great things.
Yep.
But I think there's some follow-up questions about that.
Yeah. Pat, did that answer your question?
Yeah.
Okay. I'd like to also say that Pat ended up at doing research at MIT Prime. So I feel like Pat, you'd end up going to MIT regardless of what Daniel has just said.
It's a safety school. I understand. Don't worry about it. It's fine. Don't feel bad. No, seriously, I feel great.
Okay, cool. And so next, so what can students applying to colleges for CS do to increase their chances of being accepted? So we talked about what kinds of schools and also what you should value, but like how about just tangible things that students can do?
Yeah.
Besides taking our classes, of course.
Actually, I don't. Hang on. This was unsolicited, but I will say this. When I first started in computer science, I was halfway through college. So when I talked to Ben, a very old friend of mine, who said his students were doing X, I was like, wow, I was not doing that until I was out of undergrad. So you guys are doing something really very unusual. So I don't want you guys to forget that.
Cool.
But
Thank you.
with regard to applying to colleges in general, the first thing to say is that applying to colleges is a crapshoot. It really, really is. Equally talented people can apply to a number of top schools, and it will seem random. Of course, as I said before, distributions matter. So if you have a higher GPA, you may get into slightly better schools than someone who has a worse GPA, whatever. But as an individual student, you don't care about distributions. You care about outcomes, right? You don't care if like, oh, I had a 50% probability I could get into Yale. I didn't get into Yale. Who cares?
Mm-hmm.
And so the recommendation that I have to people applying to college, and actually a lot of different application processes, is that it is not sufficient to be notable. It is not sufficient to be credible, but you want to be notable. So credible, what does that mean? You have what is the SAT out of now? 1600 or 2400?
1600. 1600.
Yeah,
1600. Okay, you have a 1600 SAT 4.0 or 4.3 or whatever GPA, like whatever, the highest GPA. That's credible. But you know what? A lot of people are credible. A lot of people are credible. And so what that's one of them. She's very upset.
Is it Charlotte or Lucas?
That's Charlotte, our younger one.
Okay.
Thankfully, mom has them tonight. Maybe yes, she does. Okay. So it is in many ways challenging to be a credible candidate because you have to do a lot of hard work. But I would argue it's almost the easier thing to do, because to be credible is to follow a formula. Like, okay, I got to have a good SAT score. I need to do XYZ activities. I need to have this GPA, blah, 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 blah. But the lesson that I would want to impart is that you must think from the perspective of, for example, the admissions officer, or if you're applying for a job, the career or the interviewer. They see a lot of really excellent people. And so they are looking for notability, not credibility. So as an example, if you were just someone who was really interested in computer science and was like, oh, I was interested in computer science. I did like, these competitions. I got like third place, blah, 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 blah. Fine. But what really stands out to admissions officers is something that they can remember. Like, imagine if you had to read 1,000 applications. Like, just to all the high schoolers out there, imagine if you had to read that many applications. I remember when I was trying to hire for people, like people gave me like hundreds of applications to read in 3 days.
Yeah.
I don't remember anybody.
Right.
And it's unfortunate. It's not perfect. It's unfair. You can say whatever you want, but that's how it is.
Right. And being able to play the piano is like now just an expected talent or skill.
Unless you are incredibly freaking good at playing the piano.
Right.
Anyway, sorry. I want to stray a little bit away from being so good at X. One of the things that I think is a little bit underweighted, a lot of people applying to colleges are focused on this activity or that activity. A lot of that gets blended into the noise also. Like if I'm reading applications, like hundreds of applications, they all kind of blend into the same. The one constant that everybody has, that everyone has to read, is the essay. And this is a place where I feel like people do not spend enough time. And the essay is really a place to show, and this is getting a little bit beyond computer science and all that stuff, admittedly. But it is a place to show intellectual maturity. Now, what do I even mean by that? So it's really easy to say, oh, in freshman year I was like this, and then in junior year I was like this. I learned X, Y, Z, and therefore I was better in junior year than I was freshman year. End of essay. And you would not believe how many essays fit this mold. So the somewhat controversial advice that I give is, before you write your college essays, don't read 50 successful Harvard essays or whatever. Read the New York Times Modern Love. It's a totally different topic, but it can show you the breadth of how you can describe a range of human emotions. And I think that depth is the thing that is most lacking among the people that I have ever seen write college essays. And if you actually go back, let's say you read the Modern Love articles and you go back to read the 50 successful Harvard essays or whatever, you will find a lot of them actually are much more introspective about, whatever the topic may be, or the applicant themselves. And so this has nothing to do with computer science anymore. Right? And I think that's probably right. I mean, most of the folks who are thinking about colleges on this webinar are probably thinking about liberal arts colleges or engineering colleges, for which you probably want a little bit more of a general application.
Right, and if they do, some of the students specifically do know that they want to major in CS, this is also like applicable within their college summary or college application summary.
You're absolutely right, Jenny. I will caveat, I cannot claim to know anything about college admissions, but if your college has specifically said the computer science faculty is admitting you from you bunch, and we are going to pick from you, and we are looking for this thing, you should follow their guidelines. You shouldn't listen to anything that I've said. But generally, what I've seen is that there are very few ways to differentiate among college candidates. One of them is, of course, extraordinary achievement, which is not realistic for everyone. So I was not one of those people. So the major way that you have is via this essay.
Awesome. Okay, we are half an hour in, so I'm going to quickly move on to the next part because we have two more parts. So the next part would be is career. So like just to kind of reel it back in to CS. So what do you enjoy most about your career and what do you dislike?
I'm laughing because I sent Jenny a copy of my answers beforehand. The thing that I like most about computer science is that there are so many interesting things to work on. I could work with this friend on a financial services application to help people better manage their mortgages. I could work with this friend on people to help people better handle their way through this shutdown. I could work with this friend to improve the way we can process drug screening, so we can develop drugs faster for people who need them. So there are so many things that interesting things that a computer science can do. And I actually think this is the thing that I dislike the most about computer science, because there are so many things that you can do. And I think for the parents who are listening, they will know this for sure. But maybe for the students, the strengths of any one particular thing are often its weaknesses, and vice versa. The weaknesses are often the strengths. So the fact that you have so many opportunities as a computer scientist is a wonderful thing. But if you let it distract you, it can actually be very challenging. So that's why I say the same thing as like and dislike.
Can you give an example of why you think being bombarded by like all these opportunities would be something that you dislike the most about what you're currently doing? Is it like multitude of distractions or missing out, FOMO, fear of missing out?
Okay, we've got it. Okay, hello. So, future computer scientist, maybe? So,
Oh, we're gonna be so distracted now.
okay, well,
No, in a good way.
我们声音小一点，声音小一点。Sorry, can you repeat your question? Sorry.
Can someone else also repeat my question? So, what do you enjoy most? So it's more so like an example of why it would be very difficult. Why this is an element that you dislike about computer science, having all these like breadth of applications that you can have for your field. Like, is it because there's constant bombardment of things that you could work on and not knowing like what the priority is, or is it like fear of missing out on certain opportunities?
I think it really depends on the person. So for some people, it might be like fear of missing out on opportunities, but I think for me with these kids, the priorities are a little bit different. So I won't speak too strongly in that direction.
But for you personally, you mentioned that that's something that you dislike, that there are so many interesting things to work on.
That's sort of a, oh my gosh, I have so much money that I'm swimming in, like I can't even know it. No, it is absolutely a wonderful thing that computer scientists have such. Hey, Xiangma. Okay, Lucas, can we go watch over? Sorry.
No worries.
Okay, go over there. Okay. Yeah, it's definitely something that is from a very privileged perspective, and that's why I think computer science is such a great place to be, because you can have that privileged view.
Right.
But distraction, if you're thinking about long-term career success, it is something that you have to be wary of, and everyone. Every business person, blah, 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 wants a computer scientist who can do, XYZ things. And so you do have to be somewhat discerning about how you make your choices. So rather than frame this as, oh, woe is me, dislike about the field, whatever, I should actually frame it as, this is a wonderful problem to have, and just use your best judgment.
Okay.
Make your, yeah.
Most of the maybe you can talk a little bit about some of the research projects you've worked on and how you ended up picking them from like a wide array of opportunities. How you ended up choosing.
Sure. I mean, the great theme of everything that I'm going to say is most of what I've done is the result of accident or pragmatism. So, artificial intelligence and machine learning is a very hot topic these days, and that is an area that I happen to spend some amount of time in as an undergrad. And so when I applied to PhD programs, that was the same area that I was looking into. And certainly the companies that I was working with were also interested in those things. So the two major projects that I work on, one is, they're both with Intel, but one is with Intel proper, and the other is with an Intel sort of offshoot group. One is going from the perspective of how do you use artificial intelligence, how do you use systems, computer systems to improve machine learning and artificial intelligence. So we work with neuroscientists to help them process brain image scans. And so the pitch, of course, is how do you read and program human minds? But going the other way, how do you then use artificial intelligence actually to better design the chips that are doing the artificial intelligence in the first place? And so my work cuts in both directions.
Okay, for the less technical audience, can you maybe repeat what you've just said, but maybe in more like layman's terms, like talk a little bit about maybe like what AI is, and maybe some of the more like examples of maybe what's like currently like products that's out there, or like something that's more tangible for people to grasp, or like movie
Sure.
reference,
I
programming the
will
mind.
I will try, and apologies if I do not succeed. So I view machine learning and artificial intelligence as any way of generalizing what you have learned to some greater context. So for example, let's say I don't know anything. I'm looking at Vikram, and I only see the screen of him. I see his lovely face. I see the t-shirt. I see the earphones, but I don't see the back of his head. Now, I believe he probably has black hair on the back of his head. Maybe, I don't have any hair, so I don't know. I don't know too much about that. But that is only an estimate. I'm guessing he probably has a head of black hair behind him, but he may turn around and have a head of red hair behind him.
It's actually blue hair. No, I'm just kidding. Yeah, it's black hair.
I mean, he might. I mean, he may be very into this sort of thing. And so for people who have learned about, for example, linear regressions, I typically say one thing. I say artificial intelligence, machine learning, all that stuff. It's just a little bit more complicated version of linear regression. You are giving a bunch of data, and then you're trying to find, y equals mx plus b. What is m and what is b? You just have a lot more m's and you have a lot more b's. To the folks who do not know linear regression, it really is like when a person is trying to figure out something they don't know the literal answer to, have them actually think about, how would they guess what the answer is? Like, what does the back of Vikram's head look like? And you know, I see some black hair in the front, you know, maybe. And there goes my laptop.
Yep. Okay. Yeah.
And so a lot of our work becomes a lot less mysterious and consequently a lot less sexy that way, because we are really trying to say, given the things we've seen before, can we reasonably predict what is going to happen in the future for a situation we may not know about? And this is a situation that humans have to go through literally all the time. Like, I think the milk is going to be in aisle 9, but I haven't been in this grocery store before. So I guess I should find where the milk is. It's probably in the back.
Okay. So is that something that is a struggle for you with the research that you've been doing, or is it does that make it more? Is that the challenging part of it, or is it the part that maybe like and have an affinity towards?
Yes, I would say that's the challenge in sort of two ways. One is we both have to understand what our models are doing. Like, if your model makes a decision like, oh, I should, the back of Vikram's head is red hair. Well, you know, I kind of want to understand why the model feels that Vikram might have red hair, because I sort of think Vikram might have black hair in the back of his head. And so that there's that sort of interpretability, understanding what the model is doing. But then, of course, there's also designing the models themselves. I want to be able to make a prediction about what my models should and should not be able to do.
I see. Okay. We actually don't have too much time left, so we have to go through these pretty quickly. But yes, the next
Sorry,
question.
I'll be quick.
No, it's totally not your fault. I've been really enjoying this. But yeah, so what has been your greatest success so far?
So I jokingly said in my responses to you, Jenny, that it's getting married, having kids. And actually, you know what?
Professional success.
Probably still the same. I will double down on that. In
Okay.
fact, I will say, so in my notes, I said, for smart, motivated people, you know, getting your life right is actually harder than getting your career right. Now that I'm 10 years graduated from Harvard, a lot of my peers, you know, they have good careers, but they don't have any direction with where their life should go, professionally, romantically, you know, family, none of that stuff. So the life stuff is actually pretty hard. Vikram, your back red hair will do you well. Don't let it go. Sorry. Okay. So in terms of actual professional success, I think probably. This is a little bit of a nuanced answer. So I will say that the willingness to try new things is probably the thing that I'm most proud of. So, for example, I did start in several well-paying careers, and I wanted to do things and be more interested in places that were maybe a little bit less well-paying. To me, that seemed like a very natural decision. To others, that may seem very heretic. The thing that I would say, probably mostly to the parents, not for the kids, because they'll do that anyway, it's that we must optimize to our circumstances. So certainly if we did not have the fortune and privilege and resources that we have now, I would not make the optimal.
I think Daniel cut off because maybe Wi-Fi issues or
That I did now. So I would not have said.
Oh, wow,
That is
Daniel, you
something
cut
that I
off.
feel.
You lag.
Okay.
There was a slight lag. I think it was like 10 seconds, 5 to 10 seconds or so. Do you mind repeating what you just said?
So to the parents, it may seem painful if your children are choosing less fortuitous careers. But, well, sorry, all joking aside, we must optimize to the environments that we're in. So certainly if Lisa, my wife, and I, we found that we were not in such fortuitous environments, we would probably not make the choices we would have made. We would have probably optimized for just more money, more resources, right? You want to stockpile those resources. But in this time of, current administration aside, relative stability and great fortune for engineers and people thinking about this kind of career, you can make these kind of decisions that may seem way too risky, but in the context of the current environment is actually okay. Like you're taking a lower paying job at a faster growing company, for example. And so I would just encourage people not to shy away from that.
Right, and that kind of segues into my actually a question that a parent had submitted prior to the webinar. That why did you decide to pursue a PhD after working in investment banking, where I assume that you can make a lot of money.
So I hope this parent is on the call because I have a story for this parent. The great family joke, not just on my side, but also on my wife's side of the family, is that every time I change jobs, my salary cuts in half. Now, this has happened 5 times now. I'm a PhD student, so some enterprising KTBYTE student out there can figure out what I was making post-grad. So the question, why did I decide to pursue a PhD student? There's a neat answer, and there's the real answer of life, I suppose. The real answer of life is that I was working at a hedge fund and then Goldman Sachs, i.e. investment banking. And the culture at the investment banking firm at the time was you work there for 2 years, and after 2 years, if you don't have a better job or you're moving on, it's actually sorry. Okay. So if you sorry. Okay. Look. Okay. So if you sorry, where was I?
If you don't work for like 2 years and you don't move on afterwards.
Thank you so much. If you don't work there, if you work there for 2 years and you don't move on afterwards, people actually look at you funny. They're like, what did you do? Like, you couldn't get a better offer. And so that was actually the culture.
I see.
At Goldman Sachs at the time. So
you were peer pressured to leave.
Yeah, and actually this is something that Goldman Sachs only, I mean, it's not recent to me, but certainly recent to most people who are listening to this recently they're trying to combat this. Like, we train you people for 2 years out of undergrad. Why are you going to this other thing instead? But back in my time, you were encouraged to leave essentially.
I see.
And my wife, Lisa, she was working at McKinsey. She still is. And she really enjoyed it. So I went there. I went to management consulting for a little bit. That the only reason I went there was because of this sort of cultural bias within investment banking. It wasn't just Goldman Sachs, it was every investment banking firm. Like, if you were still there after 2 years, something was wrong with you. And it wasn't until, I was at McKinsey, and this startup, they saw that I had a computer science background from undergrad that was doing sort of computer vision stuff, plus the business background. They wanted to hire me. And once I started working with them, I was working on the business side, but I eventually was working on more of the technical stuff. And I really just enjoyed being on the technical side. And, one thing led to another, and I was applying to PhD programs. So it wasn't like some premeditated thing. It was very sort
Right.
of as
And
you
then you
go.
worked at a startup after McKinsey?
Yes, yes.
Okay.
And
And
they
was that
were
also
working on,
technical?
yeah, so I started working out on more of the business stuff there, but it grew to be more technical. And I was like, this is actually much more enjoyable. I should go do these things instead.
Nice. And I think that transitions nicely to the third part, which is the last section, which is work. So I guess, yeah, so you've pretty much effectively described what you do. But what about breaking it down to what you do on a daily basis?
Sure. The way I always explain what I do on a daily basis is it's part of this giant nested loop. And this is part of how any company works, I guess. You have like the top level, this is the goals for the entire company, this is the goals for the division, this is the blah, 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 all the way down. But certainly for me too, I'm a PhD student, so my role is to do research. What does research mean? It is to discover new things. I'll get into that in a second. New things people didn't know before. And the process of discovering new things involves a lot of this, nested loop. So on a day-to-day basis, I will examine the data that I have generated from the previous day. And I'll say, oh, this data does not square away with what I thought the data should be. Why not? And so I spent a bunch of time figuring why not. Why doesn't this data match? And when I figure out why it doesn't match, let's run some more tests and so on and so forth.
Okay. And
So
for
that's really
in terms of the exact research projects, do you have are you working on a dissertation or a thesis? Or is this more of your day-to-day for working with the professors or the faculty?
Oh yeah, this is related for a thesis. The one thing that's very, very wonderful about computer science, and for anyone who's eventually considering a PhD in computer science, is in many fields, your PhD may not align with what your professor needs or what the people who are paying you needs, but in computer science, it's actually very aligned. So I am being advised by a professor at Princeton. I'm a student at Princeton. I'm being paid by Intel. But all of them want the ultimate same goal, which is let's produce more computer science research. And that's actually one of the really wonderful things about computer science, which is not true of all other fields, unfortunately. But,
I see. And then what would be the most challenging aspect of doing research?
So the way I talk to most people about research, if they haven't done research already, most people have read textbooks. And whenever you read a textbook, let's say Milligram's experiment or whatever, or any of the experiments in your physics textbooks, or Watson and Crick discovering DNA, that is not only once in a lifetime, that's once in a generation, that's once in a century kind of research.
Right.
That's like the Michael Phelps cross Usain Bolt cross LeBron James cross whatever, like that's the kind of rarity that happens, but that's in your textbook. And when you read about that, you're like, okay, yeah, sure, like Milgram did blah 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 whatever. Obviously, idiot. And so we really take for granted how much failure, not just for that researcher, but for all researchers to get to that point really was. And so the most difficult part for me as a researcher is to remember that. It's like, okay, oh man, my experiment didn't work. My tiny experiment that doesn't even matter. And even if like it was right, the result doesn't actually show anything that big. Who cares?
Right.
And that's the challenging part. But of course, the benefit, the what you realize is that, you know, all of that research that people do read about in textbooks, it did require all of those failed experiments.
Hmm.
And if I can contribute to those failed experiments, my name won't be in the textbooks, and that's okay.
Hmm.
But
Hmm.
like, I help guide the next people who will say like, yeah, that Daniel Suo guy stuff didn't work. Do not do that. Do this other thing instead.
So it's one built on top of another. Yeah.
You know what? Those arrogant pricks, I helped them. I told them not to do my thing. Okay. You know what? And so when oh gosh, this is embarrassing. I don't know who said this. Someone said, "I stand on the shoulder of giants," and that's really true.
Right.
And I think that's both the strength and the weakness of research.
Right. And do you think that most of your peers have this is just my personal question for you, but like do you think that most of your peers have a similar mentality as you do? Because like I do know like being a PhD student can be really stressful and it's hard to not be discouraged when you do face failure.
I think I probably have better perspective than most PhD students only because I have things in my life outside of the PhD,
I see.
my kids. If I didn't have them, I would totally understand where they're coming from.
Hmm.
It is very easy to get stuck in like your entire value is, it feels like it's based on your results. And that is actually not true. And that's a general problem in PhDs, not just with computer science or even PhDs, just research in general,
Right. Right. Right.
all sciences. Yeah. Uh,
Right. So we're 1 minute till 9. I feel like yeah, I think you've answered the following questions too about like contributions, your job offers, and if you actually would like to elaborate more on like what you feel like. I know you're being really humble, saying like, oh, your research is insignificant, but I'm sure it's like very, very vital. And so, would you like to elaborate more on maybe like how you feel your job offers to society as a whole on a more optimistic light? For what you've been
uh,
working with on at
sorry,
Intel?
sorry. What do you mean, job offers?
Oh, so how do you what contributions do you feel like your job offers to society as a whole? Because you have been pretty uh, humble with what you've been saying so far about what you've been doing.
Um, I guess the way I view my research is the way I view most Silicon Valley startups. So, uh,
Hmm.
hey, this is an app to help you connect with your friends who are, on the bathroom at the same time to share your experiences about. Okay, obviously that's very silly, but what I'm getting at is that computer science and software is just this incredible thing. It is a magnifier. And of course, as with any tool, it could be used for good, it could be used for evil, but certainly we would like to use it to magnify the good that it can do in society. But in
Hmm.
order for it to magnify the good in society, it has to permeate through society. So you need all the dumb shit that's going on
Hmm.
in order to permeate, right? Like you need the people doing the dumb ideas, like
Hmm.
uh,
Right.
you kind of need that.
So you
And
know what not to
so
do.
that's an
You build off of that.
right, and see what sort of goes and what sticks and what does. And that's certainly in a business context, but I view a lot of my work in a scientific context in the same way. I'm the stuff I'm working on is not as laughable, maybe, but it's also a lot less understandable.
Right.
Uh,
Right. Right.
but it's sort of the same thing. We want to try to expand um, the fundamentals of the fact that computer science makes the marginal cost of distribution essentially zero. How do you
Hmm.
expand that to all fields? How do you actually benefit, like say, health sciences when you can do telediagnosis, for example?
Right.
That's crazy.
Right.
It's such an obvious vision, right? But when you get into the details, there's a lot of complication. And so that's exactly where I place something like my research. It's insignificant in the large scheme of things, but you
Right.
absolutely need people like me, like just toiling away, like figuring out all the things. And maybe my thing doesn't work. Fine, whatever.
Or it would work.
Maybe that is. Oh yeah, sure. Maybe it would work, and I will be paying your salaries, all of you guys. But more likely,
Vikram smiled.
maybe more likely it won't work, and you'll be. I'll be begging you guys for jobs because you guys are. Oh, actually, I'll come back to that. I do want to say something about that. Uh, but the it's actually kind of incredible what people are able to do, and to just say like, hey, we're contributing to that, and people who are doing great things, they can look at our work and say, that work didn't work. We're going to do something else. Even that is valuable.
Okay. Well, we are at 9:03. I'm going to open the floor for questions right now. There actually have been a few that people have asked during the call, during the webinar. And so the first actually is from a student, I believe, called Violet. This is about education. The question is, I'm going to LHS2. What are your tips for success in high school that not many people may know?
Oh, geez. So this question is hard to answer because I don't know your optimization function. So I'm going to guess your optimization function. I'm going to guess your optimization function is to get into college. Gosh, there are parents on the line, unfortunately. So as far as classes go, you really want, for the classes that you don't particularly care about, still do well in them. This is a challenge that both Ben and I had. Ben, I'm calling you out on this. Classes that we were not interested in, we did not really participate in. And that is not something that I would recommend, because that's not, unfortunately, how the college game works. So, you should pay a minimum attention to those. But for the classes you are interested in, really try to think about what is beyond those classes. What are some, where are places you would like to take the questioning? Because as I said earlier, it is very difficult to distinguish between college applicants, except via, for example, the essay itself. And if in the essay you can really articulate what you are doing differently, that actually can make the entire difference. And so there's quite a bit of political stuff around, like, Asian American people applying to colleges these days, and I assume most of the audience is Asian American. I think it is in fact difficult to apply as an Asian American, because not because you are Asian American, but because the typical Asian American application is relatively formulaic, and that is where, if you are going above and beyond your coursework or whatever you're interested in, doesn't have to be coursework, that is where you will have your advantage, and I think you should focus on that.
Okay, and then we have another question from Audi Lim, which is it better to be well-rounded in school? I would imagine yes. It's very important to be well-rounded, especially if you want to go to a liberal arts school, which is all about being well-rounded. I think, Daniel, you're frozen.
Sorry, I missed a bunch. Well-rounded, something, something,
Oh,
something.
yeah. So a question from Audi Lim, which is it good to be well-rounded in school?
It sounds like this question is it better to be well-rounded versus something else, i.e. particularly good at something? Gosh, at the risk of sounding like a total asshole, you should be well-rounded, but also be really good at something. But what I really mean, sorry, wipe that aside for a second. What I really mean is that, yeah, you should be well-rounded, I guess. You generally want to do well in your classes, and I guess if you play sport, you should play the sport. But again, it's you have to think about the college admissions process from the perspective of the admissions officers. They are reading thousands of applications. It is not their fault. They're not being racist. It's just they're literally reading thousands of applications.
Mm-hmm.
Right. What makes you notable? And so far, out of the hundreds of people who've asked me this question, I only have 2 answers. So I don't claim to be an expert in this. I'm not an expert in this. But the only 2 answers I have is A, you are really, really, really good at something. So you won the Chopin International Competition at 18. Mm-hmm. Okay, who did that? I didn't do that. Or you have a very mature view on life, for example, and that comes through via the essay. So this is getting a little bit out of the CS and KTBYTE theme, but I really do think the college application essay is a very, very undervalued way to make a difference. Most people, they write a college application essay, and you will write your college application essay. You'll put a lot of time into it, and you'll think like, oh, I thought so much about it. But forget about yours. Read anybody else's, and it will sound stilted. It will sound like a robot wrote it. There won't be much insight. It won't tell you much about the person. And this person that you're reading from could be like a 4.3 GPA, unweighted, 20 million AP, whatever. But there are so many of those people. And so the essays that are introspective and show a sort of gravitas and understanding about, I guess, learning life beyond the years is actually way, 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 way more impressive than any like CS, I suppose, that you would do.
Right.
If you're purely talking about from college admissions perspective. Obviously, if you want to learn CS, you should take KTBYTE courses. No, actually, like I did not start CS until college. You guys are doing the right thing, starting early.
Yep, and our students are around the ages of 8 or 9. So
Lucas, you hear that, Lucas?
So Lucas 7 more years for Lucas.
Yeah, I know.
Yeah.
I gotta get on him.
Okay, cool. So, any of our panelists have any other questions? Vikram, Charles, I think Charles joined late. Pat, if you have anything?
I have like simple questions, like what coding language do you use?
Sorry, Jenny, I have like basically endless time because the more time we talk, the less time I have to spend getting the kids to sleep. So let's, keep talking. Sorry, Vikram, keep going.
We should probably end it at like.
I'm joking.
Actually, we're 11 minutes ahead of time. We should end it soon. So after Vikram's questions, and I think.
Yeah, just more simple questions like what coding languages do you use? What's your favorite? Stuff like that.
Sure. I think my answer is pretty pragmatic. It's the right tool for the right job. And I think these days, Python is an incredible programming language to start out with, to do most sort of data analytics jobs. When you're really trying to get at an answer that is not super dependent on computers, you just want to know what the answer is. You want to get there quickly. You don't want to have to think about programming too much. or this is your first programming language, I think Python is actually excellent.
We teach in Java.
It
Can you talk about how great Java is?
I will get to Java in a little bit, but the reason why I think Python is really great is because it is simple. However, let's talk about Java. So the reason why I think Java and, for example, C++ and those kinds of languages are also important is that they teach you a little bit more about, what is beyond, like, what if you wanted to do more than just answer your immediate question? And what I mean by that is, let's say you wanted to say, you go to middle school and you ran a vote and you want to see who voted for this versus who voted for that. And you also wanted to say, like, which grade voted for which things. Python is probably a good language for that. You don't want to spend too much time worrying about like the types that you're using or whatever. You just want to get to the answer, right? Python is maybe a pretty good answer for that.
Okay, cool. Sorry, I interrupted somebody.
But if you want to do a little bit more than that, if you want to build a system, let's say I want to help the middle school decide how they should rank their students. I can't just do like this one-off analysis or whatever, and I want something a little bit more serious, a little bit more reliable, then you may want to look at something more like Java and C++. But at the end of the day, of course, it's always right tool for the right job.
Right, and we do say that it's not about the language. It's about just learning the way to think, like computational thinking, and to be able to like solve complex problems. And the language is just a tool. We primarily teach in Java because the APCS is taught in Java. And if our high level classes, you do learn Python, but a lot of it you'll be able to pick up on your own.
And that is a very practical choice. I would say that this is exactly right. If you are thinking, oh, I should learn Python instead of Java because of blah, 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 and Java is the worst thing in the world, I would strongly disagree because let's say you know English very well and only know a little bit of Spanish, but if you don't know how to reason in English, how are you going to reason in Spanish? In Spanish, you may not know all the words, but you can use analogies, you can use whatever translations that you need to, but you still know the concepts. And so,
right.
More as long as you know the concept, yeah.
It's not the language itself. And a lot of parents do come and ask us like, is there a Python class, or like can we learn
okay, I have a great answer for that. Look, okay, computer scientist right here. Python is like English. If your child cannot learn Python on their own, oh, my wife is telling me to be quiet. I'm getting too excited. If your child cannot learn Python on their own, you have to ask, do they know English?
Ben's laughing over there. Okay, perfect. All right, I think that's a good note to end the webinar on, unless, Daniel, you have anything else you'd like to add?
No, just answering questions.
Okay, great. So I thoroughly enjoyed this, and if anyone has anything else that they would like to ask, I have our email here. You can email us at inquiry@ktybyte.com. We'll try our best to answer those. I don't want to bother Daniel anymore that I already have. You could also call us in this number, and then visit KTBYTE.com to learn more about us, our classes, maybe sign up for a free trial if you're not currently our parent or student. So yeah, that's all we have for today. And thank you so much, Daniel. I really appreciate you taking the time to talk to us about this and to enlighten these young folks about your perspective on life and what the priorities are. And yeah, I think it's a very good perspective.
Get married and have kids.
Vikram, you hear that?
No, don't.
You don't have to come to work.
Don't listen to anything I have to say.
Okay. All right. I'm gonna let you go now, Daniel. All right. Have a good night. Are you currently in Massachusetts?
I'm
Oh,
in
are you
Princeton,
in
New
Jersey?
Jersey right now.
Oh, Princeton. Okay, so I wasn't sure if you were home or okay. Never mind. Because you were visiting over the Christmas
Yes.
break. Yeah. Okay. All right. Thank you guys so much, everyone. Thanks, Vikram. Thanks all the other panelists.
Bye.
Bye.